All right, it's 1 o'clock, and I'm extremely excited today to introduce Karleigh from Livestock Water Recycling. And she's going to be presenting on Beyond Biogas, the science of post-digestion treatment. And I will just say personally, I'm extremely excited for this topic. I think one of the things we've heard is that oftentimes to make biogas projects scale, we need more resources at a single location, and that's really going to probably change how we think about digestate or manure management. And I think this is going to be a really exciting opportunity to further that discussion. I know I've been looking forward to it for months now. So thanks for coming to join us today, Karleigh, and talking us through a little bit about livestock water recycling, your company, and some of the treatment that you guys offer to help make this more practical.
Awesome. Well, thank you very much. Good afternoon, everyone. Thank you for the introduction. I'm very excited as well to be here. I was saying earlier, I've listened in on quite a few of the different webinars over this year, and they've all been really good. So I hope that I can contribute and add into that as well and provide some good information. Today, I'm going to be talking a little bit about the company that I work for, Livestock Water Recycling, and our manure and digestate management technology that we can implement in on anaerobic digestion projects, and looking at really going that beyond the biogas and looking at the digestion treatment and how integral that can be for these projects in, getting them off the ground, helping them move forward, and everything that can be encompassed within that. We have seen a lot from our standpoint at LWR that digestate treatment can be a missing piece a lot of the time in these anaerobic digestion projects. And they could be a reason that these projects maybe don't continue on after they get up and running because it's thought of that afterthought, and instead of being a forethought of looking at the waste management and really trying to change the perspective of looking at this as resource optimization instead of it being a waste product. Ooh, and I gotta click on my screen here. There we go. So to start things off, I thought I'd give a little bit of a background on livestock water recycling, kind of who we are. We have been around since about 2010. We have a parent company before us, kind of worked oil and gas industry more, oil water separators, air stripping, and then really kind of saw a shift wanting to look into the livestock industry of, we see these lagoons that are full of a waste product, and there's a lot of water content in it. There's solids in there. There's nutrient. There's a lot of value. How can we look at extracting that and being able to process that so that we can bring some more value to these farms? And within that kind of same timeline, looking at anaerobic digestion and the digestate in the same light of there's a large volume, there's a lot of nutrient, water, solids in there. There's a lot of value. And how can we extract that? How can we do something more with it? And again, like I had said, and you'll probably hear me repeat quite often, how we can change that perspective of waste management into resource optimization and looking at, can we add profitability? Can we increase the sustainability of these operations, of these sites, of these farms? And so we're going to kind of dive into from livestock water recycling's perspective and the technology that we offer and how that can be implemented specifically when we're looking at anaerobic digester facilities. So question being, why even bother going beyond the biogas? Why is it important? We have the digestate, we can handle it how we currently are. Is there really a need to go any further? And like I said at the beginning, we have seen time and time again projects fail or not be optimized because the digestate treatment was thought of after the fact. And it really needed to be a part of the beginning discussions of, from a standpoint of the farm that maybe is going to house the digester, what are their ultimate goals that they're wanting for their digestate treatment? As we all kind of know, your inlet coming into your digester is very similar in volume to what's coming out. And within that, we're not really losing any of our nutrient value in our digesters. And so we're still going to have that volume come out on the back end. You're still going to have all your nutrients. We maybe see some conversion, like when we think of nitrogen, we'll see some of that organic nitrogen convert in the digester to more inorganic. And so how can we optimize how we're going to use those nutrients, what can we do with them, as well as, I'm sure we all know digesters are not 100% efficient. It would be fantastic if they were, but they tend to not be all the time. And so we do end up still with some volatile solids that can come out in that digestate. And so, looking at on the sustainability side, is there opportunity to see further emission reduction from that, which could lead to, when we're thinking of digesters, CI scoring, is there any improvements that maybe we can add to the overall project? Is there possibility for further carbon credit generation from this if we're looking at the digestate coming out and becoming the farm's ownership again? So we're really looking at that full scale scope of improving sustainability and profitability for these projects when we're really digging into the digestate treatment. So in how can we look at from LWR's perspective or any technology integration with renewable natural gas projects, what are the different ways that we can fit in with this? So I have kind of three scenarios up here on the screen. In scenario one, we can look at the concentration of manure as a feedstock going into digesters. So if we have a liquid manure coming from, say, a dairy farm or even a swine facility, we're looking at concentrating up all of that volatile solid into that solid that we would pull out, and then using that as our feedstock into the digester. And really what this is doing is an opportunity for the site is to maybe look at, a smaller capital cost on the digesters. We could have a smaller footprint because we've concentrated all of that volatile solid into a smaller volume. Then we look at scenario two is where we look at more of that kind of hub and spoke model, where we would have a centralized digester, and then we have multiple farms in the area that we could use as feedstock and bring in. And so again, from that economic standpoint, we can concentrate up the solids, which within that concentrated solid is that volatile solid, which is what we want to feed into our digesters. We can concentrate that up at multiple facilities and then haul it into that central digester. And then scenario three is what we're going to be mainly focusing today's discussion on, and is looking at the treatment of digestate post-gas production. And so we're looking at, again, the nutrient monetization and utilization that we can improve on, as well as the increased emission reductions that we could see from digestate treatment. So I'm going to cover now kind of the two different technologies that LWR, Livestock Water Recycling, offers for digestate management. And this goes as well for manure management. It's the same equipment, but we can treat different feed inlets into us, whether it's manure or digestate. So the first one I'm going to discuss is what we call our first wave system. And this is our liquid solid separation. And we have a low energy consumption from these units, but a really high efficiency on the solids removal. So we're looking at enhancing the bioliquid separation. And within that separation, we're looking at that nutrient separation. So when we're taking out the suspended solids in the system, along with that suspended solid, you'll see your phosphorus be removed as well, and that remaining volatile solids. So again, if your digester, is running, say, even 60% efficiency, there's still that kind of 40% of volatile solids that could be coming out in the digestate that when stored into a lagoon is still going to have the opportunity to maybe break down, and you're going to see that emission or greenhouse gas be released. And so we can capture that now with the first wave system and capture that volatile solid, the suspended solids, and your phosphorus, and have that now as a separate product. And then you'll have a filtrate liquid that would come off of that system as well. That's where you're retaining that inorganic nitrogen, your ammonium nitrogen, as well as your potassium, and the salts from the digestate are going to come out in that liquid fraction. So from this kind of standpoint of how this is going to optimize a facility, we're looking at the, maybe lower storage capacity needed from this, which we can see then lower hauling costs, lower spreading costs. When we think of now a filtrate liquid compared to just your raw digestate, your filtrate is essentially a solids-free liquid that has that inorganic nitrogen that's plant available, and we can put that out through irrigation and through pivots. We could even go through drip tape with it so that you could utilize that liquid now as a nitrogen product to get out to crops that would be maybe needing that in your springtime. And so instead of treating this as, your raw digestate, same as manure, fall applications, maybe this opens up some opportunity to apply some of that in your spring months when your plants and crops need that nitrogen. And we can then have that storage requirement maybe level out a little bit because we can put that out at different times of the year. So that's really how I kind of look at a first wave system, is looking at your solid separation, but then within that solid separation, the nutrient separation that we're seeing from that technology. So the next system then, because just taking a next step further, this is what we call our full plant system. And so this is looking at, after we do that solid separation on the front end, taking that filtrate liquid and treating it even further so that we can have a clean water product be recycled off of the back end. And then we're going to take all of that nutrient and concentrate it into a smaller volume on the back end as well. So you end up with 3 different outputs from this system. So we start off, we do our liquid solid separation on the front end. We then go through some different filters and membranes. We have reverse osmosis included in this. And that's where we're seeing that clean water comes out of that RO unit. And so in this system, your optimization for the site is a massive reduction in storage requirement of your nutrients, because again, solids off the front end has that volatile solid and phosphorus. And then off of the back end, we have a concentrated nutrient liquid that can be then stored in your lagoons. And then again, land applied onto crops. We have that inorganic nitrogen there, great product to go out when the crops are needing that nitrogen, maybe in the spring. And then you have your clean water that you can, reuse on farm. You can irrigate that out onto the land. But overall, we see a very big reduction in storage requirement of your nutrients on site. Within that then as well, because we've concentrated, those solids and our nutrient liquid down in volume, we can now look at this as a saleable product that is not going to be the exact same as, your commercial fertilizer products, but they are a lot more concentrated than just that raw digestate or raw manure. And so there's a bit more of a value to it that you could sell that off farm or off site from the anaerobic digester, as well as, that opportunity of, increasing profitability on the project as a whole. So a little bit closer look at the outputs from the system. That kind of teardrop graphic on the left-hand side gives you a really good breakdown of, when we're thinking of a full plant system, what that kind of breakdown of volume looks like. So about 17% is going to come out as that really concentrated nutrient liquid. We can see up to 75% of clean water recovery from raw digestate through our system. And then the remaining, 8% by volume is going to be that solid product that comes off of the front end. So again, as a recap, when we're thinking on the nutrient side of things, your liquid nutrient concentrate is a much more concentrated version of that filtrate. That's your ammonium nitrogen and your potassium, and your salt content would be in there. From the water perspective, essentially, everything's come out of it after you've gone through reverse osmosis. There's not really a lot left in that water. And so it's a great product that can be reused on the farm. We've even looked from, different anaerobic digestion projects. If you have, say, a feedlot that's wanting to put in a digester, you could reuse that water and recycle it back to the front end, and really, really dig into that circular economy of adding that water back to the front end to help water down that feedlot manure. And like I said, going through using that for irrigation purposes is a great use of that water. And then your nutrient solids again is your phosphorus, and the majority of your organic nitrogen will come out in that solid component. You'll have a bit of trace amounts of your potassium and inorganic because there's still moisture in there, but it is a more stackable product. It's about 24% dry weight of that solid, so it's a lot easier to handle. And when we think of that, reduced hauling costs and application costs, we're looking at a product now that is your phosphorus that you could move to fields further away a lot more economically than just as a raw liquid digestate form. We now have that solid product that you can put a lot more nutrient into a truckload and take it, 10 miles down the road. Whereas before, economically, maybe, 3 or 4 miles was kind of the max for that phosphorus. So it really opens up the opportunity of, geographically where you're going to apply your nutrients on your fields. If you've got some land further away, opportunity to sell that off farm because it's in that solid product. And as well, maybe application timing as well from the different outputs just gives you a little more opportunity of how you're going to utilize those nutrients in that digestate. So kind of, full circle here of when we think of, benefits of digestate treatment, I have a couple up here and I think I've, touched most of them, but we really do look at the environmental benefits as well as the economic benefits. And kind of the main things that I wanted to focus here is, when we list things like watershed protection or soil regeneration, nutrient control, really what we're seeing with that is the utilization of those nutrients now of instead of it being all just in a raw digestate form, it's a large volume, fall's the only time that we can apply that digestate. Having treatment of that digestate now opens up those doors of, putting down the nutrients when crops are actually going to utilize it. So we see less leaching, we see less runoff of our nutrients, and overall we're not just, washing away that value of those nutrients. We can actually utilize them. And from that perspective of a whole project, when we think of anaerobic digestion, it really is important to take all of these pieces into consideration when we're looking at the project from a whole. And that digestate treatment does mean, if we are going to treat it, the storage requirements, what does that look like? The current permits for applying our nutrients. Do we need to see what those changes would look like? Can we better how we're applying our nutrients right now? All of those can be taken into consideration, and we can see those benefits from digestate treatment with technology like LWRs. Another piece that I wanted to touch on today in my presentation is from, how LWR can stand apart from other technology is really the data analytics that we have with our systems. We have a very advanced system that has sensors kind of placed all throughout it. And so we are collecting data, every 5 minutes off of these systems, and we're seeing what's coming into the system versus what's coming out. And we can track what that solid recovery is. And then from there, you really can determine, what that volatile solid recovery is. We can look at the phosphorus recovery. We can see where our nutrients are going. And on top of that, when we're collecting all of this data, it really helps to open up doors to those, digital marketplaces like fertilizer if we want to have saleable products. When we think of RNG, we can prove out if we want to look at improving CI scoring, we can actually capture that data in real time to prove out what that benefit looks like. And then, maybe future opportunities down the road of maybe we can look at nutrient credits or carbon credits after digesters of is there further opportunity that we can look at with all of this data to access new marketplaces? Again, trying to look at that overall picture of sustainability and profitability. How can we improve that? And within that data analytics, it also is integratable very easily into, the current existing anaerobic digestion facilities. So whether it's, from day one, which is, our best case scenario that we're a part of those conversations, we're looking at digestate treatment, right off the get-go. We can seamlessly integrate right at the beginning of these projects going in, but we can also come in after the fact of if a digester is already operating today and they want to add on digestate treatment. It's very easy to just add that in to the current operations and integrate that technology in as well. So in my last kind of couple slides here that I have, wanted to go through two different case studies just to kind of give a little bit more perspective of this type of technology, digestate treatments in real applications happening now. So the first case study that I have pulled up here is a anaerobic digester on a dairy farm in Michigan. And this system was installed back in 2015. This is one of our earlier installations that we have at LWR, and it went in to treat digestate in 2015. They are milking at the time about 2,400 milking head. I think they have increased a little bit on their herd size since then. But some of their benefits that they saw from this was, immediately that reduced transportation costs, reduced volumes that they had to handle, just with a first wave installation going in. Really another big one that they, have commented to us before and repeatedly is around that nutrient management of being able to separate out that phosphorus and improve the overall management of nutrients. They are now in the process of creating and marketing a product of their solids as a fertilizer product to surrounding farms, to greenhouses and nurseries as well. So this has really helped them in that, next expansion of their business. And at the time when they had installed our system, they also then were able to start taking off-farm waste and charge tipping fees from adding on the first wave treatment from their systems. They added this in and were able to manage their storage, manage their nutrients more. And so they were able to start taking off-farm waste. Specifically at this site, they have a brewery just down the road. So they're taking brewery waste and mixing it in with their dairy manure as well. So there's lots of different ways that digestate treatment has improved their already existing anaerobic digester. And then kind of their success story from our standpoint is after they installed this first system, they had a sister dairy down the road, and they did install a second system after implementing this first one and seeing, these benefits happening in real time on their operation, added another facility. The second case study that I wanted to just kind of go through quick kind of takes a step outside of anaerobic digestion, but does kind of fit back into this whole conversation. We have a site in Washington State that put in our first wave system and then went through carbon credit generation. They went through the validation and verification process through under the Vera registry for methane avoidance credits. And so they are currently generating, they're selling their credits today through methane avoidance credits with just our first wave system. So they do not have a anaerobic digester facility and are still able to generate carbon credits on their farm. And so they did this back in 2019. They installed, they went through the process of doing, like I said, validation, verification, and are generating around 10,000 tons of credits per year from their farm and are selling that into inset markets. And so those credits are going kind of through the dairy supply chain to consumer good companies that are purchasing them to go against their carbon credit kind of balance sheet. So this is a great example of how that data capture has allowed these farms these new opportunities. And where it fits into our discussion today with digestate treatment is the potential for down the road opportunities that we could look at post-digestion of additional credits, whether it is carbon, maybe it's a nutrient credit. I hope it doesn't happen, but maybe even water credits, down the road of being able to recycle water and those different avenues that could come along. All of this data capture helps play into that opportunity down the road. So this is kind of a next step, something that we're looking at, down the road from now is potential of unlocking those additional carbon credits at anaerobic digestion facilities with post-digestion treatment. Right now, it's not a thing as of now, as we know, when we're doing renewable natural gas or if we're doing electricity, we have pathways for credits to fall under there. What we're looking at is there an opportunity for that volatile solid that is not being broken down in the digester, comes out in the digestate? If we're going to capture that, is there an opportunity to show, that carbon credit potential that could be created there with that capture of volatile solids? And is there a potential to stack that with the current RNG or electric credits that are happening already with the farm and what that could look like? Because we already have these verified protocols with our technology out in the marketplace, um, is that a possibility? So as of right today, it's not, but that is something that we're continuously, looking at and seeing the different opportunities that are out there, and is something that we definitely strive for of how can we add more revenue or profit to these different facilities that are already in place and what possible opportunities could come about from it. So as kind of just a wrap up here, my last kind of slides, really from our perspective, at LWR, we have at this point, we're about 40 systems, maybe just a little north of 40 systems that have been installed. That's throughout the US as well as in the United Kingdom, in Ireland, and in Lebanon. So we feel very comfortable in our technology. We, I believe, are somewhere around 3 or 4 million data points now from all of our systems, of data that we have captured off of this. And so that's, manure and digestate data that we're capturing every day, and going through and using that, in these new market spaces and allowing our farms or our sites to add and look at new opportunities on farm, as well as, filling out if they have to do their permitting and their nutrient management plans. All of that data helps and is a part of that whole conversation, from these sites. So we really are a global leader in manure and digestate treatment, and not just a technology provider. We would like to think that we are, first and foremost, we want to help farms in looking at the best opportunities that they can have at farm. And if they have anaerobic digestion, doesn't stop there. We can look at digestate treatment and all the different opportunities available for them. So with that, I do hope that, the main message that you guys can take away from today is that Beyond Biogas is within reach, and digestate treatment is a resource opportunity and optimization, and not just, a waste management problem that we have. There's many opportunities that we could look at in maximizing sustainable impact, improving nutrient management, and then tapping into new revenue and markets that are out there in the space today and even, in the future in the next couple of years, hopefully. So I want to thank everyone for attending and for the opportunity to speak with everybody, and happy to answer any questions if there's anything.
All right. Thank you so much, Karleigh. Can I get you to stop sharing your screen? I'm going to do logistics, let you take a breath, and you have plenty of questions to answer. So don't worry, you're gonna be here a little
Perfect.
while. There's a lot that showed up for us. So a couple things. Make sure I share the right screen there. Okay, so on October 14th, we have Mark Licht. He is an associate professor here at Iowa State, and he's going to talk about cover crops for biomass and the risks and challenges in integrating cover crops, hopefully for biogas production systems. So I'm excited about that one. We had our previous webinar on harvesting these things. Mark's really going to focus on how do we integrate them into cropping systems and how does that change the risk profile for how your corn and soybeans might yield. So looking forward to that. You can find the archives. They're on the YouTube channel, Dr. Manure, or if you want presentation slides, they are available for you there. We do have an anaerobic digestion newsletter, so we summarize what we talked about at these things, and I try and make a few other comments. Hopefully those articles are useful and tell you which webinars that you really have to go back and take a look at, because there's a lot of information on there. So if you're interested in getting that webinar, I promise it's only quarterly, or that newsletter, it's only quarterly. You can sign up, or I'll give you a moment to scan the QR code if you're watching on your computer and have your phone handy. Okay, now the fun part. There were so many questions. that I almost don't know where to start. But one of them was, could you walk us through just a little bit more on how the first wave, that solid separation, works to create carbon credits? What's sort of the mechanism there, and how did you have to prove that?
Great question. So the real basis, and I am not a scientist by any means, so I talk very, very simple terms, which hopefully translates well. But we can generate carbon credits from our first wave in what we call a methane avoidance credit. And so in manure or digestate, we have volatile solids within the solid makeup of that manure or digestate. And so when we are capturing solids in our first wave system, we're really targeting the total suspended solids portion of your total solids makeup. And so when we remove total suspended solids, we see a very high removal of the volatile solids along with that. And so in a methane avoidance kind of landscape, if the manure or digestate is going straight from the barn or from the digester out into a lagoon, we are aerobic. And so we're having a lot of breakdown of the organics. And within that organics is that volatile solids. And when that breaks down and releases the gas, that's where we're getting our greenhouse gas emission and we're getting our methane. And so if we can effectively remove that suspended solids and volatile solids out of that liquid stream, and we're now storing that, whether that's stacking it, if we're going to go further and compost those solids, we're removing that volatile solid from sitting in that lagoon and breaking down and releasing methane. So that's my very basic kind of term or way of explaining of kind of how that carbon credit is generated. So it's that reduction in emission from removing the volatile solids. The process that we went through, we partner with a third party. One of the main ones is 3 Degrees, is a carbon credit developer and broker. And so they are the ones who worked with us to work through the methodology and protocols and kind of built all of that out of what that looks like. And so with our systems, like I said, we have all that data capture. So we can see the inlet kind of TSS numbers versus the outlet TSS numbers. And then we can calculate out what that volatile solids removal or recovery is. And it's from that that we're getting kind of the methodology and calculations of, exactly what the carbon credit number is and associate to that. But hopefully that kind of answers that question.
Perfect. The IPCC estimates methane emissions from liquid manures based on VS in there. So as Karleigh said, having good records on how good of job you're doing separating VS lets you figure out what your carbon credit could be. So their
Yes.
system is integrating that in there for you so that they actually have data on how well it's performing. So I think
Yep.
that's the big thing. All right. I think you said this later, but for scenario one at the dairy farm, what was your target solids essentially to feed the AD? Or in this case, I think, what is the solids content that would be coming out of your wave one system? And I think I heard you say 24% solids.
Yes.
Yeah.
Yeah. And so within that, we can less that, if we want to hit more of just like an 11% or 12%, again, depending what the digester is and what they are wanting to take in,
Mhm.
we can kind of change that a little bit. But yes, out of ours, the solids at kind of 24%. So then pending if liquid needs to be added in or anything, we can do that. But solids out of it would be that 24%.
Perfect. And that's really tailored based on what else is in your mix and how far you might be moving it.
Exactly.
Yeah.
Yeah, definitely.
Have you thought about squeezing that harder with a belt press or something to make it drier if I really wanted to move it, or what sort of opportunities have you explored there?
Yes, definitely can be added on for our kind of all intents purposes with our technology. In that first wave system, you kind of saw there's a micro screen or an incline screen, and there is a screw press that sits at the bottom of that. And so that's where we kind of get that 24%. If there's, wanting to go drier or further, obviously it's just adding on, the next piece of equipment to it. And so even on a screw press, we partner with Van Bauer for our screw presses. So it would just be, partnering with another technology to add on, whether that is a belt press. If you wanted to go really far, we've had farms that have dried their solids even
Mhm,
further. So yes, lots of opportunity to add on to get, specific products out of that.
mhm. And then you mentioned that that product often ends up with a good amount of the phosphorus that you started with.
Yes.
And we have sort of a question about what does that mean for their nutrient management plan? Is there such a thing as making that product too phosphorus rich where it's hard for that farm to have it, or what's going on there? What advice can you have for us?
Absolutely. I have yet to hear too phosphorus rich.
Mhm.
That would be great, maybe if we could that. But no, typically, again, I think it comes down to then, your land base. Obviously, every farm is going to be just slightly different than their neighbor, but the opportunity to, lower application rates would be kind of your biggest thing in there that you could use less product on your field. So maybe that does mean you need more fields. Typically, it becomes more of the economics of trucking that further. And so we have most cases farms that go, I've got fields, 10 miles away that I can't get my manure or digestate to. I really need to, I want to, but I just economically, it doesn't make sense for me to do that. And so now we can open up and move it there. And so we're able to just kind of spread that phosphorus out on the land base that the farm has now instead of keeping it very condensed in, that couple mile radius of your barns or your lagoons.
Beautiful. And I think the comment I'd make on that is sort of if you're thinking about old-fashioned horizontal beater manure spreaders where it was with bed pack manure, that's probably not what you're going to use to apply this. You're probably
Yes.
switching to a vertical beater or something that gives you a wider spread pattern that's still reasonable to hit those lower rates. But
Yep.
definitely dial those rates down, able to sell it or move it to further fields and still take full advantage of it.
Yeah.
All right. Do you have a full plant system installed in the US going all the way through reverse osmosis?
We do have a couple systems installed. I believe just one of them would be treating digestate
Mhm.
all the way to clean water at this point.
Although the digestate treatment is slightly easier maybe than even the manure treatment. We have less maybe recovery in the solids to start with because we broke some of those down. But after that, it's relatively the same once you get through that solid separator.
Yes. Yeah.
Yeah. And then the question they had really about that was water quality output. Does it meet animal drinking water quality? What are people doing with it? What are some of the options that you see?
So it would meet, if you were to take it out and test it, it does technically meet a potable water standard. Obviously, that really comes down to, the maintenance and upkeep. We're talking about membranes, we're talking about filters. So the unit itself does have a self-cleaning cycle on it, but we also do have, maintenance items of, further extended cleaning of taking those membranes out, giving them a really good wash. So if everything's kept and everything's running, we're following the maintenance requirements of this would meet potable. We don't advertise it as being animal drinking water quality, just from, we want to make sure that everything's safe and that we don't have, sensors on this reading, every single parameter in that water. To ensure that, say, if something got missed in maintenance and we had a membrane that maybe wasn't 100% clean and we had something foul and it came through, we don't want to be causing any issues or harm to these animals. So, really, for the most part on farms, I would say irrigation is one of the biggest uses of the water. Obviously, again, not everybody has pivot set up, depending where you are in the world. And so, again, I will say this, a full plant system isn't a great fit for every farm. Clean water is great, but it's maybe isn't needed. So irrigation, I would say, is the biggest one. On top of that, then, just reuse on the farm, as, wash water, that sort of thing would kind of be your main ones. But the biggest one, is through irrigation. We'll have, sometimes, they'll put it back if it's a flush dairy, and using that clean water through their flush. If they are, really, there's not a lot of, excess clean water then, if they are going to reuse it, as a closed loop flush system, they wouldn't have a lot of extra water left over. So I'd say those are kind of the two big ones. They're reusing it through a flush or irrigation.
Perfect. All right, now the tough question for you. Can you talk a little bit about CapEx, operating expenses of sort of maybe the first wave and then the full system?
Sure. I will keep it open of, email me directly. I'd love to quote systems if there's anything really specific. But just kind of as a general, we do have, 5 different sizes of equipment, which makes, giving cost numbers a little difficult because it really does range. We have systems down, for 100 cow dairies, up to, 6,000 cow dairies and plus. Like I said, kind of broken over 5 different system sizes in both a first wave as well as the full plant system. Just as kind of a rough idea, that full plant system is about double the cost of what the first wave system is, just because we are adding quite a bit of filtration onto the back end. And then from an operating cost perspective, in our system, we are adding a polymer product in to flocculate the solids. That's how we achieve a really high suspended solids removal and efficiency rate. And then within that, a high volatile solids removal rate. So we do add that flocculant product in. And that's kind of your main operating cost. And that just is correlated to the suspended solids. So the lower the suspended solids, the lower amount of flocculant we need to use. So again, there's some variability in there, but more than welcome if someone has specific projects, please reach out to me after and would be happy to discuss through all those numbers.
And that flocculant product helps you a lot with phosphorus recovery in that first wave
Yes.
system. Yeah.
Yeah, it does. Yeah.
Okay. If you had hog manure from let's say a deep pit, very Iowa question here, what sort of analysis, presumably for mostly nitrogen, but if you have phosphorus or potassium, might we expect from that liquid nutrient concentration? And I don't know that you have any of these installed, so I'm going to give you a rough number first. We probably start 50 to 60 pounds of nitrogen per 1,000 gallons in a deep pit. And you gave me that sort of 15 to 30%. That might mean if I had 30% and got all my nitrogen in that fraction, I'm at 200 pounds per 1,000 gallons of nitrogen. Is that roughly what you see?
Yeah, I was gonna say, from like a percentage wise, kind of what we say is in that liquid concentrate from a nitrogen perspective, about 60% of the ammonium nitrogen is going to come out in your liquid, and that remaining kind of 40 is in your solids.
Hmm.
And then the flip side for your, what did I say? Okay, inorganic is 60% in your liquid,
Yeah,
and then it would be, 40% of your organic
organic
and
nitrogen. Okay.
nitrogen. Yeah, getting confused there what I'm saying.
Yeah.
But
So
more of
then,
the ammonium in
yeah.
the liquid than in your solids, and then opposite,
Mhm.
more organic in your solids than in your liquid.
So then for deep pit swine manure, we might be talking 150 pounds of nitrogen per 1,000 gallons, given where we start at roughly in Iowa,
Yes. Yeah.
which would take us for a corn crop following soybeans, you might only put 1,000 gallons of manure. This is no longer manure, but this liquid
Yes.
fertilizer product on, which I
Yeah.
think puts you in an interesting spot. That's high rate for commercial application, and it's really
hmm
low rate for some manure application equipment. What are farmers using to put that on? Are they diluting it back down and running it with their irrigation? Sort of what's been the approach that you've seen with some of that? And since you do a lot of dairy systems, maybe it doesn't get nearly as concentrated as what we're at, so maybe it's not as big a deal.
Yeah, I was gonna say kind of yes to all of them.
Okay.
Again, depending on what they have, if they're tanking it, if they're drag lining, if they have any irrigation on it. In the dairy side, I would say, we're not seeing as much. Again, we have a lot less of a full plant system where we're seeing, the higher concentrated nutrient liquid.
Hmm.
Um, and so I haven't heard of anyone, diluting that down. From a hog perspective, I don't have any full plant systems to go that far. Maybe you would have to in that case, which again, with the system, obviously, it's piece kind of by piece, it's modular. So you can just run, a first wave and make a filtrate that's maybe more dilute. And then if you only need to make so much clean water, or you just want to turn on the back half of the equipment to make some more concentrated, at that point, you could really dial in
Yeah.
on what you specifically needed, to really get into it, which would be incredible to work through that with a farm. So yeah, on a deep pit example, I don't know really what that specifically would look like, but you might have to look at dilution, which I think the system as a whole allows you to do that quite easily.
Mhm. And I just punched some numbers on what your dairies might end up at, and it looked to me like you might be putting on 3 to 5,000 gallons of sort of that stuff, which makes you
Yeah.
look like swine manure and standard equipment probably doesn't look so bad then. And yeah.
Yes. Yeah.
Uh-huh. All right, so we had a great question about salt content in the manure. Where's the
Yeah.
salt ending up? What are we doing? Am I going to go from not having a salt concern to, wow, I'm putting a lot of salt in this fraction all at once. Now should worry about salt?
Yes and no. So again, no matter what, the majority of your salts are going to be in your liquid
Mhm.
soluble state. And so on a first wave with our filtrate, really, I think, application wise, you're not going to see a lot of difference just from your raw products. It can become a concern on your concentrate because we are just concentrating it so much more after the RO. Um, Definitely, we've had this conversation, and we think of, Idaho, Utah, those kind of areas, can be a real concern because of the high salts kind of already there in place. So it is something that then has to be monitored after. Unfortunately, solution on salts, when we're thinking of treatment, can get expensive after this state. You're really looking at evaporation, crystallization, any of those become extremely power intensive. So as of right now, there's just industry-wide not a great solution. But yes, when we do concentrate, it's something to think of. Again, kind of the mindset that I look at it is your volume is reduced. So what are the opportunities from a land-based perspective that we can put this out? Can we open that up? Is there more? Can we go to those further fields? Do we have neighbors that we can put this on their land? Really looking at it full scope and maybe, from a bird's eye view of where and how we can apply those. But definitely needs to be taken into consideration from a liquid perspective,
Mhm.
um, of
Especially if you're
that salt.
using irrigation equipment, making sure
Yes.
you're avoiding plant leaves as you're putting it on.
Yes.
But I
Yeah.
think one thing to keep in mind for sort of the Iowa or Eastern Corn Belt is you're probably not changing the salt to N ratio a whole lot. So I'm worried about putting it on the
No.
plant, but the salt to N ratio and that stays the same. So as long as we weren't in a place where we were seeing salt build up in the soil before, probably won't now. So Iowa, we get enough tile drainage generally that unless we have 4 years of drought in a row with minimal tile drainage, salt won't be a problem. And you'll probably be in the same situation with your soil here. So it's more of a, if I'm putting it onto that growing crop, thinking about sort of that impact.
Yes, I always kind of say, through any really sort of treatment, we're not getting rid of any of the nutrients or, salts within it. We're just kind of changing, what form there may be in that kind of aspect. So,
All right, the questions might be coming in as fast as you're getting them answered for me, which is okay. The next one is sort of about N2O and greenhouse gas emissions. So N2O is about 300 times CO2. Methane's
mhm.
about 30. Have you looked into or tried to get any carbon credits related to N2O, especially with putting a lot of your nitrogen into a fertilizer product and not having maybe ammonia volatilization in a stored lagoon? There seems opportunities there.
Absolutely. Really great question. And yes, definitely something we're looking into. We have, just from the gas perspective of reductions, we have quantified that somewhat in some tests, just kind of initial stages at this point. But we do see reduction in that. Um, the next kind of step then is, yeah, looking into the credit piece of it, of how we could apply to that is something ongoing that we're looking to do kind of down the road. It's not into fruition just yet, but definitely on our radar of something that we want to, bring and add. Again, another revenue stream that we can add on to projects. The more, the better.
Mhm. And then the next question is just where does that potash end up? Which product?
Mainly the liquid.
Mhm. We did get a comment that reverse osmosis water is arguably safer as potable water than some groundwaters in the Midwest. It's
Yes.
certainly probably cleaner than some of the water that we drink in the Midwest. If you do drink too much reverse osmosis water, just remember to let it re-equilibrate, get some CO2 in it, or it can dissolve your bones. So that if we're going to use it as potable water, right, especially for milking cows where calcium demand is high, it's
We
yeah.
have seen that specifically. We had a farm test it against his well water and went that exact thing. It was much cleaner. But then the flip side, there's no minerals in that RO water either.
Mhm.
And so, the benefits that we do get out of some groundwater, you do lose in on that as well. So it's, yeah, it's a two-sided sword.
All right, and then we do have another cost question for you. Any chance we can squeeze you to give us a rough cost per cow or a cost per pound of phosphorus removed, or just some ballpark number to sort of have in mind?
Yeah, so from a, again, cost per cow, kind of difficult. Operating standpoint, cost per gallon. If we look at a first wave, we're probably somewhere about half a cent per gallon as a treatment cost. Versus if we want a full plant system all the way to clean water, we're probably a cent to maybe cent and a half per gallon of a treatment cost for the full plant system. So again, clean water is great and it's amazing and probably is going to become a more frequent conversation that we have, within North America, I think, as a whole. But it's not always the best fit for everybody, pending what those goals are for nutrient management or just manure digestate management.
Absolutely. And I think that's a great point. We didn't hold this webinar thinking it was a fit for everyone, but it fits certain places. And for
Definitely.
perspective, if you say it's 1.5 cents per gallon, the average cost of manure application in Iowa is 1.8 cents a gallon, right? So depending on sort of how far you are moving manure, these systems start to fit on the right farms.
Exactly. Yep, definitely.
We did get a question about how does the coagulant flocculant that you're using impact bioavailability of reactive phosphorus?
So, as of right now that I'm aware, again, not a scientist myself, but there really should be no effect. We have worked extremely hard in sourcing a product that is safe for land application. You're not going to see effects. We've looked at, really ensuring that we have a biodegradable product that
Mhm.
we can implement. We're not using any, alum or, harsh metals that maybe municipal waste treatment plants are using. We wanted to ensure that we're picking products that are going to be safe for application. And we have worked with the DNR in a few of the different states on, specifically in the solids, what that would look like and have gotten approval for that land application of them. So
Mhm.
that's definitely something we wanted to ensure that we're not adding anything that's going to be harmful or impede.
Yeah, I think that's a great point. I think most polymers do lower soluble reactive phosphorus substantially at land application, but most of them break down relatively quickly in soils, so it doesn't change long-term
Yeah,
phosphorus
yeah.
throughout that first growing
And
season even.
yeah,
Yeah.
when you're mixing it in and it's breaking down into water, and then your sunlight comes into effect too of when we get that cultivated into the ground, we see some pretty good breakdown.
So with your 25, 24 to maybe just a little bit higher solids content, do you have anyone taking that to do, let's say, biochar with it is our question.
Not right now, but on the horizon. We
Mhm.
have quite a few conversations of looking at that to go into biochar, and the carbon credit side of biochar is another piece that we're looking into quite a bit right now.
Perfect. And then we made it to the end of the questions, which means I finally get to think about mine. And you gave us three great scenarios sort of to think about. Is it a manure treatment system? Am I trying to concentrate VS to move to a digester? Or is it
Mhm.
sort of some combination of these? And as you think about maybe what you're selling right now, most farms are using it maybe just as a treatment system. Is that fair?
Yes, I would say so for the most part. Yeah.
Okay. Which I think makes a lot of sense. But your scenario one to make a product to move to a digester, I thought was really intriguing and maybe not
Yes,
something that we've explored to the full potential. So yeah, it definitely
definitely.
gave me something more to think about.
Yes, and I think really where kind of scenario one and scenario two has come into was California market is kind
Hmm.
of the first place that we have seen it and are kind of developing it a little bit further, is looking at, really dilute manure that they have there and being able to concentrate it up. But I think there are, a number of other applications that we could look at, especially when we think of maybe some, smaller dairies that doesn't fit to have their own digester. How can we, bring them into this picture as well and give that same opportunity to them?
And that's exactly what I was thinking. I see a lot of pig farms where we're not going to be able to support a
Hmm.
digester. What are the opportunities there? So I really appreciate you pointing that
Yeah.
out. So once again, thank you, Karleigh, for joining us today. That was a great presentation. Thank you, everyone, for all
Perfect.
the questions. If you do want more information on the system, Karleigh is definitely willing to provide it. And
Yes.
if you want a quote tailored to your farm, it sounded like she would maybe provide those too.
Absolutely.
Yeah.
Absolutely. Feel free to reach out. Thank you so much for the opportunity to chat and share more about our technologies.
That was terrific. Thank you. Thanks, everyone.